Landfills are one of the oldest waste management methods to exist, simply because of the fact that they are so easy to make. All people have to do is dig a pit and throw their trash into it for a bit, and then boom, a landfill is made. There are many problems with doing that, however, especially when hazardous waste is involved. That is why landfills are now regulated by RCRA and have been since the late 1970s. RCRA is the Resource Conservation and Recovery Act, and it is a piece of legislation passed in 1976 that creates guidelines for how hazardous and non-hazardous solid waste is managed in the United States. According to RCRA, hazardous waste is defined as any garbage or refuse, sludge from a wastewater treatment plant, water supply treatment plant, or air pollution control facility, and other discarded material, including solid, liquid, semi-solid, or contained gaseous material resulting from industrial, commercial, mining, and agricultural operations, and from community activities.
The U.S. has 3,000 active landfills and over 10,000 old municipal landfills, according to the EPA. However, in the good old days, every town had its own dump. According to the 1997 U.S. Census, there are 39,000 general-purpose local governments in the United States, 3,000 county governments, and 36,000 sub-county general-purpose governments. One would suspect that there are many more old and abandoned commercial, private, and municipal dumps than the 10,000 estimated by the EPA.
Landfills have many environmental impacts. Compounds such as ammonium and methane are typically produced, which may have adverse impacts if released into the environment. Residents of surrounding areas complain of foul odors and that landfills are an unpleasant sight. Prior to RCRA management, landfills were not required to have an impermeable bottom liner, which gave way to leachate plume formation.
In 1922, the city of Norman constructed a landfill of its own for municipal use northeast of the Canadian River in the sand alluvium. Because record did not exist yet, this landfill was made with no underlying liner. This landfill was operational until 1985, with waste deposited in landfill prior to 1973 being largely unrestricted and may have included substances now recognized as hazardous. Over its lifespan, the Norman landfill received an estimated 2.6 million tons of waste. The accumulation of waste, along with no liner, eventually led to the formation of a leachate plume in the subsurface. This plume is slowly making its way towards the Canadian River.
The closed Norman landfill is situated south of the Norman Water Reclamation Facility. It has two cells, with the effluent pipe from the facility being the dividing line.
I'm standing on the separating line. To my left is the west cell, to my right is the east cell. Directly behind me is the effluent pipe with the leachate plume moving in this direction towards the Canadian River.
To combat the worsening leachate plume, the city of Norman put a clay cap on top of the closed landfill. This was done to prevent rainwater from getting into the waste and bringing a high concentration of hazardous compounds into the groundwater. The leachate plume as of today is only fed by groundwater that runs through the bottom of the landfill.
To track the movement and severity of this plume, the landfill was designated as a USGS research site through the Toxic Substances Hydrology Research Program in 1994. Monitoring wells were placed down gradient of the plume, with some wells being up gradient to provide accurate measurements of the movement of the plume, as well as concentrations of potentially hazardous dissolved chemicals. Here we are over the west cell of the old closed Norman landfill. These are a couple of the monitoring wells that they used to monitor the leachate plume after it was closed.
Researchers say the Norman landfill is the most studied trash dump in the world. Scientists with the U.S. Geological Survey have punched more than 1,000 water wells into the dormant landfill.
There's a transect of wells in various directions out here, and then the sampling is done. The wells are set up so that you sample at different depths down to the bedrock. So each sampling depth gives you a little different picture of the look of the leachate and how it changes with depth and how it changes as it moves away from the source that you're seeing here.
From the usage of the USGS monitoring wells, it was discovered that the leachate plume created by the Norman landfill has elevated levels of many different compounds. The plume contains elevated concentrations of non-volatile dissolved organic carbon, methane, ammonium, sulfate, iron, fluoride, and bicarbonate. There were also elevated concentrations of detergents, pesticides, plasticizers, fire retardants, household and industrial chemicals, polycyclic aromatic hydrocarbons, and fecal indicators. Specific organic waste contaminants include DEET, BPA, P-cresol, and trichloroethyl phosphate.
As of right now, this plume does not have any major impacts to the environment. There may be some minor impacts, however, since the water table is about 2 meters under the ground on average. Some plants can uptake compounds that are dissolved in the groundwater, and these compounds could bioaccumulate in animals that eat those plants. Once it reaches the Canadian River, it could pose a greater risk to wildlife. Researchers believe in 40 to 50 years the plume will reach the river, and when it does, plants and animals in the river will be exposed to the contaminants and potentially accumulate them to toxic levels. There should be no concern about the contaminant plume from the landfill getting into the central Oklahoma aquifer, since the landfill and plume sit atop a confining unit.
There were no intentional remediation efforts made at the Norman landfill. Instead, the plume is degrading by the process of natural attenuation. Existing microorganisms in the soil subsurface degrade the contaminants after getting energy from chemical reactions like the reduction of sulfate, ferric iron, and carbon dioxide. From the USGS monitoring wells, it was discovered that the center and main area of the plume is in a sulfate reduction zone, and the outer edges of the plume are in a methanogenic zone. In the sulfate reduction zone, microorganisms reduce sulfate to hydrogen sulfide, which smells like rotten eggs. The methanogenic zone produces methane, which has a harmful effect of being a greenhouse gas. The plume also contains an iron reduction zone that reduces insoluble ferric iron to ferrous iron. Most of the natural attenuation occurs at the boundaries of the plume, where the electron acceptors are available. Less attenuation occurs in the center of the plume because microorganisms have already used up the electron acceptors during the migration of the leachate plume. Another form of natural attenuation occurring in the leachate plume is adsorption to soils. Elevated concentrations of ammonium were slowed by the soil in the subsurface. Biodegradation of chemicals found in the plume has been relatively slow, with concentrations being detected many years after they have initially been discovered.
No future treatment has been considered for the leachate plume by the city. Monitoring has shown significant reduction in hazardous concentrations as the plume has moved through the subsurface, likely due to natural attenuation and dispersion. A potential remediation technique that could be used to further reduce the chemical concentrations in this plume could be phytoremediation. Different plant species can be planted along the path of the plume, which will uptake a target chemical. For example, cattails and the perennial ryegrass are effective at uptaking iron. The common rush plant is effective at removing ammonium, while the perennial reedgrass can efficiently remove hydrocarbons. The advantages of this treatment method are that it is cost efficient when compared to conventional remediation methods, and it is environmentally sustainable.
The closed Norman landfill will continue to contribute to the leachate plume as long as there are still contaminants in the landfill. Since it is capped, only groundwater flowing through the landfill is removing the contaminants, and they are being removed at a slow rate. Because of these factors, the contaminant plume is predicted to exist for a really long time.